Hi everyone. Today we will be solving a binomial theorem question. The question says that consider the expansion of 8x cubed minus 1 upon 2x to the power of n, where n is a positive integer, and we are asked to determine all possible values of n for which this expansion has a non-zero constant term. So firstly, what is a non-zero constant term? It basically is the coefficient of x to the power of 0. So suppose we have an expansion, say 7x cubed plus 5x squared plus x plus 2. So this 2 is the constant term in this expansion because you can write this term as 2x to the power of 0. So 2 is the constant term. So that's what we're looking for in this question. So a good starting point would be to write down a general expansion for the given binomial expansion. So we can write it as tr plus 1 equals n choose r 8x cubed to the power of n minus r multiplied by minus 1 upon 2x to the power of r. Now the next few steps would involve simplification. So what we need to do is we need to isolate x. So we can do that by writing it as n choose r. I can write 8x cubed to the power of n minus r as 8n minus r multiplied by multiplied by x cubed to the power of n minus r, and then I can write minus 1 upon 2x to the power of r as minus 1 upon 2 raised to the power of r multiplied by 1 upon x raised to the power of r, and this can also be written as x to the power of minus r. So finally we can combine the x's, so we can write it as n choose r 8 to the power of n minus r times negative 1 upon 2 to the power of r times x raised to the power 3n minus 4r. So if you didn't understand this, I'll work through it over here. So we've been given, so I can write this as x to the power of 3n minus 3r, and then we have an x to the power of negative r. So this simplifies to x to the power of 3n minus 3r minus r, which gives us x to the power of 3n minus 4r. So that's how we get that's how we isolate x. Now, as we discussed previously, we need to find the coefficient of the term, which is x to the power of 0. So what we can do is we can set 3n minus 4r to equal 0. And now, solving for r, we get that n must equal 4/3 of r. Now the question has told us that n is a positive integer. So how can we let n be a positive integer? Well, the answer is that if r is divisible or is a multiple of 3, then it will cancel with the denominator, and we would be left with n being a positive integer. So that's what we're gonna do. We're gonna let r be a multiple of 3, as we can write it as let r equal 3k, where k is a positive integer. Now that we know this, we can substitute 3k for r. So we are left with n equals 4/3 of 3k, and now the 3's can cancel, so we're left with n equals 4k. Now what this tells us is that we know that k is a positive integer, so k can take on the values 1, 2 and 3 and so on. So this means that n can take on the values 4, 8, 12 and so on. So because if k is 1, then n would be 4 times 1, which is 4. If k is 2, then n would be 4 times 2, which is 8 and so on. So these are the possible values for n, and these values do continue and they go on until 16, 20 and so on. So that's how you solve question number 6.